know when you're live streaming this thing? Okay. Shall I start? Tell me when to start though. Okay. Good evening, everyone. So today we are here to talk in blockchain. Let us think and talk in blockchain today. Happy weekend, first of all. So today I will take this pleasure to introduce. Okay. Okay. Am I audible? Guys, please let me know if I'm audible. Okay, thank you. So, good evening, everyone. We are here to discuss blockchain today. Let's think and talk in blockchain. So, first of all, let me take this pleasure to introduce to you the speaker today, that is Payal. Uh, she is a SDE2. I would like to welcome Payal from the team of Blockchain Dynamics, that is BCHAIN Dynamics. I welcome you, Payal. And I would also like to welcome our lovely audience who have always been a very good support system to us to every offline and online event. Though there was a delay of 5 minutes, we would like to start right now with the whole session of today. And I would like to also tell you all that this session is of 2 days, that is today and tomorrow at the same time, 7 p.m. We look forward to the active support even tomorrow. Please log in tomorrow at 7 p.m. for the event, the continuation of today's event. So let us welcome Payal now without further delay. And I would like Payal to take on the whole session and stay tuned, guys, for the insightful session.
Hello everyone, I am Payal. Am I audible?
Yes, you are.
Okay, so without wasting any time, let's get started. Um, Hello everyone, I am Payal. I have developed a lot of POCs in blockchain. I would like to everybody to know what blockchain is and what problems it tries to solve. So I wanted to ask everybody, what do you think blockchain is? Any buzzwords, any jargons you people know? Nobody wants to answer what blockchain is. People in the audience. Okay, let's get started. What is blockchain? So blockchain is a technology. It has a lot of jargons which it combines, which I'm going to explain in very layman terms. Let's take them one by one. It is a decentralized database which stores information in form of transactions. Let's suppose it's a database. It is decentralized. It can be public or private. It is immutable. It is highly secure. It uses consensus-based algorithms. It uses cryptography. It is peer-to-peer. All these jargons combined make blockchain's definition. Blockchain is a consensus-based consensus where people take permissions, secure with cryptography, decentralized. Anybody can be the server and anybody can be client. It can be public or private, and it is a database because it stores data. But nobody can change it because it's immutable. Now let's understand these things in detail. So I understand the jargons, what blockchain comprises of, but what problems it is trying to solve. First of all, transparency. Imagine a system where everything is hidden. In centralized systems, you only see what they are making you see. Nothing is transparent. You cannot go and audit the system. The very core principle of blockchain is to keep records transparent. Uh, so how does it help? It eliminates tampering. Anybody can go and check what is happening and who has changed anything. Okay, transparent. But then anybody could be able to see anything, then they can change everything. Now, then we have immutability. So immutability is In order to keep transactions transparent, we need to make everything immutable. Otherwise, everybody can change everything. If anything is changed, once the data has been written onto blockchain, no one, not even a system administrator, can change it. Well, this is a privilege. So, as a provider of data, you can prove that your data hasn't been altered. And as a recipient, you can be assured that your data hasn't been altered. These details are specifically more important in financial transactions because everybody wants to keep their money safe. But in traditional database systems, a person with a higher privilege can alter your data. This might lead to security concerns. Blockchain.
Payal, 1 minute, please. Please, like your PPT is in the first slide. Uh, eh, Sorry for interrupting you, though.
You cannot see my data. 1 minute. So
It is in the
sorry.
first slide. Yeah, that's fine.
Uh, you can see it in first slide only.
Yeah. Only the first slide is visible.
Just a second. I'll unshare and share. Is that okay?
Yeah, sure.
Is it visible now?
Yes.
Yeah. Uh, we were at immutability. Sorry to interrupt you guys. Can you all see my PPT now?
Yes, Payal.
Yeah. So immutability. Why blockchain is immutable? Because if we want to incorporate transparency, we have to make it immutable. Otherwise, anybody could change anything. As I explained about traditional database systems, where an administrator was having a privilege to change anything, this is taken care of here. The next, the next buzzword, which is why blockchain is famous, is decentralization. So how essentially decentralization helps is basically the thought process behind building a decentralized system on blockchain was to reduce effects of a milling user who can destroy your system if it is on centralized. This is essential because you cannot trust a single entity, and a single entity is not allowed to take decisions for the complete group. So that is why decentralization, which follows the saying for the people by the people, and everybody loves democratic decisions. Okay, so these are the problems it is trying to solve: transparency, immutability, decentralization. But what am I getting from this? If I build an application on blockchain, what are my benefits? What is my TRP? So there are many benefits of blockchain. First and foremost is high availability. Any number of nodes can go down at any time, but it does not affect your network. It is highly secure. Why? All transactions are cryptographically secured and they provide integrity. Each block is connected to all the blocks before and after it, which I'm going to explain later how it is done and exactly how does it look like. But in general, cryptography is how everybody can see everything, but yet it is not open to everyone because it is hashed. Then comes faster dealings and cost savings. So, by removing third party intermediaries and overhead costs for exchanging assets, blockchain has the potential to reduce transaction fees significantly. Isn't it a very good benefit of blockchain? In any financial industry, especially in settlements, blockchain plays a vital role because it does not require lengthy process of verification, reconciliation, and uh, and quicker settlements. So there is a version of agreed upon data which is available and which can be shared upon financial organizations. Verifiability and auditability. Any record of the blockchain in the transaction can be verified by anyone. Now that doesn't mean records are always openly accessible. You can form permissions who has the permission to audit it, but if he has the permission, he'll be seeing the data which is untouched, untampered because it is stored in blockchain. Okay, these are benefits, but how do I use it? How do I implement this great technology? So, uh, so this is going to be a really bad example, but this is what is coming into my mind. For example, Java. Java is a language, and then we have different frameworks implementing it, like Spring, Hibernate, or Struts. Similarly, blockchain is a technology, and then you have different frameworks implementing it, depending on the different usages. For example, Bitcoin is a cryptocurrency in itself for trading. Ethereum was built on the principle that it should be public, but then you should be able to do more than cryptocurrency functions. Hyperledger came into being because cross-border and cross-blockchain applications wanted to interact. Corda, it's a more secure and more permissioned because it was used mainly for financial banks or financial institutions. Then people wanted an application which was like Ethereum, which was based on solidity, which was flexible to implement any application, but yet they wanted it to be permissioned. So Quorum came into picture. These are famous ones. There are many, many applications which are there. You can also build your own application in blockchain. Okay, so Bitcoin. What is exactly Bitcoin and what is the relation between them? So Bitcoin, as I said earlier, is an implementation of blockchain. Whatever numbers which are there in the blockchain database, which is called as the ledger, those numbers are being tracked in Bitcoin. So Bitcoin, so who puts money in Bitcoin? No one. Imagine an analogy where there are 100 golden colored toy unicorns in this world and everybody wants it. So as supply is so meager, people want to own it. So you have created a market where demand is very high. So it can be worth millions of dollars. So connect this to Bitcoin. And that is why people want to trade in it, because its value is so much and supply is so less. So, as I told you earlier, the examples of blockchain, we had Quorum, we had Ethereum, which were blockchains comprising of public and private. But what exactly is private blockchain? What exactly public blockchain offers us? Yeah, sorry for the pause. Public blockchain. Anybody can read without explicit authorization. Anybody can write into it. There are more complex rules for better security because it is public. Consensus algorithms are complex, computationally expensive to mine and add a block. Nobody owns a public blockchain. It is on a peer-to-peer network, so everybody is the owner. Popular examples of a public blockchain would be Bitcoin and Ethereum. Private blockchains. Now, if you want to leverage blockchain technology, yet you want to have permissions because it is for your own use or for your own organization or into some stakeholders which are dealing with confidential data. So you can build your own private blockchain. Only authorized nodes can read your transactions. Security can be straightforwardly implemented because it is private. Only you can make one node as the arbitrator who will be dealing with the disputes among other nodes. You can code how disputes should be handled based on different algorithms. Many things can be replaced by legal contracts. Legal contract giving more control to one party in private blockchain. Examples of private blockchain would be Quorum, Hyperledger to some extent. So why it is peer-to-peer network? So blockchain, as I told you, it can be public or private, and it is decentralized. The major thought behind putting it into a peer-to-peer network was they did not wanted a central authority to control all the authorizations or all the data inside it. Imagine a blockchain network running on a centralized system. Anybody can hack it because it is having all the related information, all the classified information, and then that person can delete that data, can alter that data, or just form a different blockchain network replicating that. So in order to save blockchain from those attacks, decentralization came into picture, and the blockchain technology enables people to take into consideration that you can do anything. You are the server, you are the client, you you just need an account, and then you can do whatever you want. You can see whatever people connected in your network are doing and adding to your blockchain. So that was the major thought process behind making it decentralized. So enough about what it is and a high level introduction of what it entails, but how it is stored. How am I able to imagine the intricacies, what goes into blockchain? So blockchain basically is a data structure. It is stored in linked lists in our computer system. And this linked list comprises of blocks. These blocks are nothing but chunks of memory. Blockchain uses it in this way. It forms blocks. So first block is called a genesis block, and then the chain continues. Each block comprises of this data. So a block has a block header, which is the version info is the hash. There is a timestamp when this block was created. Now Merkle is a very important concept here. So as you all can see in this previous picture, all the blocks are connected one by one through chain. Now how does it enable to know that I am linked to the previous block? Imagine, um, let's take an analogy of a book. Imagine blockchain as a book. Pages are your blocks. Page numbers are your hashes, which is version info here. An entry in a page is a transaction, which are transaction ID list or the data here. It is easy to detect if a page or block has been removed or deleted from the book. It is easy to arrange the pages or blocks and identify any suspicious activity. And that is why page numbers are important in a ledger. Since pages blocks are built tightly on top of each other, it is impossible to tamper a previous entry in the ledger without somebody noticing it. Isn't it great? Nobody would be able to change it, because if it takes out one block or changes one block's hash, the Merkle tree changes, your Merkle changes, and everybody knows that this is a fake block or it has been tampered, and then that blockchain node which is trying to add this is rejected. So this is how a block looks like and a block is stored. So a block header contains metadata about a block. So it has a hash of the previous block and hash of the next block, so that it gets connected. Then you have Merkle trees. To add on to security of blockchain, what people thought was apart from having these blocks having hashes of each other, we'll have another data structure, which is a binary tree, where we will keep hashes in a top-down manner of all the nodes in the blockchain. So at one point of time, suppose I have node A and node B, two nodes. So hashes of node A and B would be stored as the root, and hashes of A and B would be the children. So if anybody changes anything, we have the root as A and B. If anybody changes A, the root would change, and then everybody who is monitoring the blockchain would know that the Merkle has changed. That means somebody has changed the blockchain. So this is how they identify. Now let's move on to transactions. So what a block contains, the data in the block is transactions. Now what are these transactions? So transactions can be anything, whatever you want to store in your blockchain. For example, let's say there is a scenario. You have Alice in US, which wants to send $10 to Bob in Australia. So in a real world scenario, she would request the bank for the transfer, international transfer. So it's going to take her 3-4 days for cross-border transactions and some meager charges based on that. Maybe for $10 it is 0.5%. So imagine that transaction being happened through blockchain. So how it will save her is, it will save her days, 3 days. It will save her money, extra money which she's paying because she wants to transfer money. So all these transactions, so this is how a blockchain would entail those transactions. Alice would request a transaction. A block that represents the transaction would be created in the blockchain. How it will be created, I'll let you know in some further slides. The block is sent to every node in the network. Nodes validate the transaction, whether it is a valid transaction or not. Maybe a Bob is a node. And then nodes receive a reward for the proof of work. The block is added to existing blockchain because Bob has already accepted it and it is a valid transaction. So transaction becomes successful. So this is how it could be transferred in just a minutes. In just so now as we saw earlier, these transactions are there. But how do we make sure what kind of data is added and what blocks are added and how they are added? Suppose it is a peer-to-peer network and I am a node. There are hundreds of other nodes who are strangers and I want to add something. And at the same time, somebody else also wants to add the same node. How do people resolve conflicts, that what I am saying is correct or what the other node is saying is correct? So that is done through consensus based algorithms. So let's take a real world example here. Let's say we have nodes and the blockchain is synchronized at the block 100th. 3 miners. Now miners, we are going to come in the next slides. What are miners? So just for the starters, miners are people who add blocks to blockchain. How they add, I'll tell you afterwards. But the way they add, the protocol is through consensus algorithms. 3 miners have mined new blocks, 101 at nearly the same time, because our blockchain was at 100 block. Now, how do they add 101 block after this block? So all of these blocks have different signatures, so they are not exactly same. So let's say the new block is 101A, 101B, and 101C, which must be the final block. So in Bitcoin, this is a problem. Sorry, in Bitcoin, this problem is worth 12.5 Bitcoins. So people who solve it, they get a reward of 12.5 BTC. So we can solve this conflict by considering longest chain rule. Now what happens is at any point of time when a miner tries to add a block into the blockchain, it adds it to the blockchain and then checks whether the other block which the hash was made and the other miners are following that chain or not. So how it is done is, let's consider Bitcoin. How it is done in Bitcoin. Conflicts are being resolved by longest chain rule. Let's say a miner receives the first block and then he will start building the next block on top of that block. For example, the 101A block, and he will start building 102A block on that. Now, in a few seconds, that miner sees another block, which is 101B. So that miner will keep an eye on that new block and the chain following it. So there are two orphan chains going on. But then he will also observe that if the next block is 102B, which is being detected from another nodes in blockchain, then it will disregard his chain and it will follow the other chain, which was longer than his chain, which is 102B. So this is how longest chain rule works. Am I going too fast? Are people following me?
Yeah, we're following you.
Okay.
Yeah.
Let's continue. So this is how we eradicate conflicts in blockchain. But how do we do that? So there are different algorithms. The basic one is proof of work algorithm. Proof of work is, as I told you earlier, what a miner is, it tries to add block to a blockchain. So what happens in proof of work is there is a node and there are transactions to be processed which are in pending state. So if I am a miner, I would pick those transactions up. I would try to generate a proof, which can be anything. For example, it's a mathematical puzzle and I have to solve and give its answer. Once I find the answer of that proof, I will broadcast the proof of work to all the nodes. And then I will write that transaction into blockchain. And if the nodes accept my code, then it is added to blockchain. So this is a simple example of proof of work algorithm, which miners use to add a block. Then there are other proof of algorithms. Then there are other algorithms also. For example, we have proof of stake, where different parties or different nodes, they have their stake in the blockchain, and based on the amount of stake, percentage of stake of tokens, they have the authority to decide which node gets added. There is delegated proof of stake, there is proof of authority, and many more. Different implementations trying to do consensus among nodes. But one thing I wanted to add, these proof of work and all are not mandatory. They are implemented inside the frameworks, and then you can create your own algorithm also. But it should be robust enough to handle the blockchain technology as you want it. So how does a block get added to blockchain? It is mined. Now, what is mining? To function a blockchain and maintain its integrity, it needs a large network of independent nodes around the world to maintain it continuously. In private blockchains, a central organization has authority over every node on the network. In case of public blockchains, anyone can set up their computer to act as a node. Owners of these computers are called miners. You can also be a miner. Since integrity of a blockchain is directly related to the number of independent nodes on the network, there also needs to be some incentive to mining. So different blockchains utilize different mining systems. However, most of them contain some form of incentive or consensus algorithms. So if anybody can mine or anybody can add a node, isn't I can fake a transaction, I can do anything which would pretend that a block would be added to it. So this isn't possible because then what I told you earlier, we use algorithms to verify it and other nodes have to agree to it. So this is how blockchain as a whole functions. So blockchain is I just want to summarize and then we will move on to attacks. So blockchain is a technology which is a database which stores data, which is based on a decentralized network, which uses cryptography. As I showed you, there are different blocks connected cryptographically. It is immutable. If you want to verify the auditability of blockchain blocks, you do it through your private keys. Again, cryptography comes into picture. You can audit if you want to modify any block in the data of the blockchain. How do you do that? You can alter the block, but at the end of the day, it would be added as a different block altogether, and it would be permanently there in the history that you have altered this block and it is added as a new block. So transparency is there. And then how do you?
There are comments telling you'll have to go a little slow because it's a little too conceptual for them to understand. So sorry for the interruption again. A little slower, please.
Okay. So sorry.
You can continue.
Yeah. Okay. So how it is decided what should be added to blockchain is done through miners. How to add it is done through consensus algorithms. Having been said that, blockchain is not a perfect system. Hackers are there who have advanced technologies who can think of ways to attack a blockchain. So there are two famous attacks which can critically jeopardize a blockchain network. First one is 51% attack. Often considered a massive flaw in public blockchain like Bitcoin's blockchain. Let's say if a single entity contributed majority of the network's mining hash rate, then they would have the power to manipulate public ledger. It is theoretically possible because blockchain is publicly open. It is likely that confidence in the currency would be lost and price of the currency will decline rapidly. It would be a very costly attack if it is on a public blockchain, because the power to manipulate public ledger lies into that node itself, which has gained 51% of the nodes. So he has the power to alter it. So this is 51% attack. There is one more attack which is known as Eclipse Attack, which focuses on the idea of crippling a node in such a way that it cannot talk to other nodes in the network. It fakes a blockchain network around it so that it assumes that I am talking to a legit blockchain network, but it is a fake one, and then they extract confidential information from it. So this is known as Eclipse Attack. But nonetheless, we can make blockchain a secure system by uh, by creating by creating applications which cater to the needs of security. Like if you're building an application which is based on Ethereum, you build your Solidity code in such a way that only few people have permission to access it or tamper or modify your data and make it more robust. Uh, that's all from my side. I am so sorry I was a bit all over the place because everything was in the starting everything went haywire. But I guess people got the crux of it and what I was trying to explain, the basics of blockchain and what the idea of it is. It is a simple technology, but not an easy one. But as you come closer to it, you'll understand what it tries to solve. That's it from my side. I am open for any questions.
Thank you, Payal, for this insightful session. I actually made points of whatever your slides had in it. It was really nice to know a lot of fundamentals of blockchain. So let us move on to some questions asked in our live stream here. I would ask Nishant to come up with the Q&A thing.
Sure.
Yeah. Yeah.
So first of all, I want to thank you, Payal, for today's session. It was really good, and sorry to the audience for the delay. Like there was some technical glitch, so sorry for that. And yeah, it was really good, Payal. It was really good, especially the memes. I must say. So like we can just start the Q&A. I'm finding first question because there are too many conversation going on in the live chat, so I have to find where is the question.
Nishant, shall I just start it?
Yeah. Where is the question? I'm not able to see. Oh yeah, here is the first question.
Yeah.
So Vishwajit is asking, could you guys please explain few business use cases of blockchain, where and when to use that? How about the cost involved compared to other backend technologies?
Okay. Good question. So Vishwajit, thank you for asking this question. Tomorrow we have a session where we will be discussing different use cases and how we can use blockchain in it. But to answer your question, blockchain can be used in majority of the industries: healthcare, financial, banks, even in education. So and it is the cost involved in implementing these applications is very less. It is compared if you compare it with different applications which we implement now, it is more or less the same.
Okay, thanks, Payal. And I think this is not the question, but Shikhar is telling that it's good to understand what exactly Bitcoin was and how we missed to become rich. Interesting. I heard it cannot be hacked as it is decentralized. So what's your thought in this?
Thank you, Shikhar. Yes, Bitcoin is decentralized, but as I explained in my last slides, 51% attack and Eclipse attack, these attacks are observed on Bitcoin networks. So we cannot say that it is a perfect technology. People can attack it, but it is very difficult to attack it.
Yeah, but it is like almost impossible because they have to be owning 51% of the electricity, like power of the world. Then only they
Correct.
can do this thing, but it's almost
Which is very
impossible.
difficult.
Yeah, it's very difficult, and it's too costly also for them.
Yeah.
So
Thank you, Nishant, for adding. I missed these points.
no problem. So let's move on to the next question. Anirudh is asking, how can a fresher get into blockchain based company?
Interesting question. So, if you want to go into blockchain, first of all, read about it, what it is, then build a small POC, a proof of concept. Take any use case, take healthcare, take educational system, and try to solve a little problem, very, very small problem. For example, your certificates. You can keep your certificates data in blockchain and then build an application showing that how it is secured to people and then put it on LinkedIn. So people would talk to you about it. People would know, put it on blockchain forums and then apply on Naukri for blockchain jobs. And then if you're a fresher, they would definitely ask for a POC. You show them that you have made this. They'll be highly impressed and you'll get it.
Okay, thanks, Payal. Can we just on our video so that like our audience can just see us? It will be good for them.
Okay.
Otherwise, they will be feeling like they are talking to someone else.
Sure. Can you see me?
Just stop sharing your screen, Payal, and then only they can see us. Sorry. Yeah. So let's move on to the next question. So Shikhar is asking again, who can learn blockchain? Is there some prior technical knowledge required for learning the same?
For blockchain, I guess if you understand basic computer systems, how it works, what is a decentralized system, how networks are connected, I think that is sufficient.
Okay.
And if you know programming language, that is more than good.
Yeah. Thanks. So next question, Tirth Gupta is asking, has there any known attacks on blockchain, like 2 types of hacking you mentioned? Any practical examples?
No, not yet. Because it's, as you mentioned, it is very difficult to make a network utilize so 51% of electricity and try to replicate it. But I can say it's not impossible. This is a theory which I came to know. That 51% attack can be done, but it is not yet done. So I don't have any practical examples.
Okay. So next question is from Vinod. He is asking, can I expect to see an example implementation in tomorrow's session?
I can accommodate. An Ethereum smart contract, a simple one. Or you want to see a POC, then we can organize a different session.
Yes, I think like if they want us to implement something, they want to learn how to implement, then we can have different session for that, separate session maybe in future. Yeah. So Sanjana Bharadwaj is asking, what is the alternative of blockchain? Like what was used before this?
So blockchain, there's no alternative because we have centralized systems and they had many drawbacks. And that is how blockchain came into picture, to make everything transparent and everything immutable. Anybody can see everything. So I don't think there is an alternative, but it is trying to solve some problems, which I mentioned earlier. Most probably permissions, so that nobody can alter data. You want to add something, Nishant?
No, it's fine. Yeah, you answered the question. And next question is from Abhishek, is this session available after live? I will answer it. So yes, Abhishek, the session will be there on our YouTube channel. You can just come to our YouTube channel and watch this session anytime, and watch tomorrow's session also, which will be from 7 to 8 p.m. in continuation with this session. So Vinod is asking, Payal, I know JavaScript. Can that help me in anything in starting out in learning blockchain tech?
Yes, JavaScript is a very good stack for blockchain. So blockchain basically can be used by any library. You can use any backend. JavaScript is a preferable one, and you can use any front end. So yes, there is a library known as Web3.js, which can be accommodated in a JavaScript code.
Correct. So I will add something to it. So Vinod, if you want to write smart contract and if you want to build something on top of Ethereum blockchain in particular, so you should learn Solidity programming language, which is an object-oriented programming language, and to handle the methods, the functions that you have defined in the smart contract using Solidity programming language, you should know JavaScript, because as Payal told, you will be using web3.js library, which is a JavaScript library, and to use that you should know JavaScript. So it's always better if you have some prior knowledge of JavaScript before building something on top of Ethereum blockchain. So yeah, that's it, Payal. I think we have answered all the question. So we don't have any more question. Audience, if you want to ask, just ask in the live chat, or else we can wind up the event. We'll wait for a couple of minutes, Payal, okay?
Yeah.
Sanjana, if you can just switch on your video and we can wind up the event.
To all the people who have attended this event, please come tomorrow at the same time. We'll be continuing on use cases. I'm sure Nishant would add to it.
So Samarth is asking answer to my question. Okay, what Samarth asked, let me see. I think Samarth is telling we don't use CPUs for mining, we mostly use GPU or ASICs. And after that he told even a modern high-end CPU can hash at a rate of 12,000 hashers per second, which is pretty slow compared to GPUs and ASICs. For example, a GTX 1080 could be around 36k hashes per second. Can I know why you still told about CPU miners?
So I was telling because you can build CPUs which would be having that much power to do it. I understand your point, it is completely valid. GPUs are technically used, but I wanted to make it more layman terms, layman people to understand what it entails, what miners are specifically, so that's why I used it. But yeah, you can use CPUs also, you can use GPUs also. What is your take on it, Nishant?
Yeah, correct. Yeah, you are telling right. Like if they will use GPU, so it will be there will be more probability for them to mine the next block.
Correct. Yeah.
Because they will be solving that mathematical puzzle more quickly, so they will get the reward, and they will be having higher probability to get the reward actually.
So that goes into a public blockchain. What about a private blockchain? So if I'm building a private blockchain, my miner would be my CPU only.
Yeah, yes.
So that applies too.
Yeah, correct. Vinod is asking, what about Python? What is a popular blockchain related Python library? Yeah, library in Python, sorry.
I know an implementation of Solidity in Python, but a library with Python, I don't have any idea.
So if I'm not wrong, there is one library, web3.py actually. So it is just like web3.js. So if someone if someone don't have prior experience in JavaScript, so they can use web3.py and they will be handling the functions that they have written in the smart contract using Python language. But what I know is that it is not stable, that web3.py library is not that stable. It have some bugs, so it's always better to use web3.js. Or otherwise they can use APIs like BlockVigil. So if anyone want to check it out, just Google search BlockVigil and you can see how to use that API in building smart contracts. So Khushi Pai is asking, I heard the word ledger used many times. Can I please know what it means and how it is related to blockchain? And
Sure.
she's telling, sorry, I'm new to this concept. It's totally fine, Khushi.
Yeah. So ledger, as I told, blockchain, you can consider it as a database. So in a database, whatever your records are, they are kept somewhere. So that is a ledger. So basically, ledger literally is a book where you keep your transactions. So it is an analogy here. So that ledger, that record keeping book, we can connect it to a blockchain network where you keep all your records in the blockchain in form of transactions. So ledger is a record keeping book, but you call blockchain also a ledger because it keeps transactions. Does it answer your question?
Yeah, I hope so. So yeah, you are right. Like ledger is like it's continuously growing ledger because each day there are so many new transactions that are getting added to the blockchain. So we just say that it is growing ledger or growing blocks in blockchain, basically. So Vinod is asking, is there a real life analogy, if there is one, to the concept of reward in blockchain? Yeah, this is a good question actually. Yeah.
A real life analogy.
For rewards in blockchain.
So in Bitcoin, whenever you mine, you get reward. In Ethereum also you get a reward. Analogy, no, but scenarios, yes. What if, there are so many applications where you mine and you get a reward,
Yeah.
which is in cryptocurrency terms.
So Vishwajit is asking, ledger is he's answering the question. Okay, fine. Okay, Khushi is telling that yes, it does answer the question. Thank you.
Thank you, Khushi.
Okay, so we are done with Q&A. Payal, thanks a lot for today's session. I think like our audience learned a lot because they were asking so many questions, and a person can ask question only if they were hearing something or they were trying to understand something. Otherwise no one can ask any question. So like thank you Payal, thank you for today's session. And like I am also personally looking forward for tomorrow's session. So audience, like tomorrow's session will be at the same time. Once again I'm telling 7 p.m. to 8 p.m. tomorrow, Sunday. So yep, join us tomorrow. Thanks Payal. So I think we can wind up the session. Thanks a lot.
Thank you, Nishant. It was great interacting with you.
Yeah,
I
actually,
hope everybody understood everything.
yeah, they understood. I think because they are commenting in the live chat. Thanks for the great section. Thanks much. Like they are appreciating your session.
Thank you.
Okay, thank you Payal. Thanks a lot.
Thank you. Let's get back together tomorrow.
Yeah.
Yeah.